Hi, this is Desmond Butts. Welcome to my channel, Alaskanlimoguy. Now, I'm going to do something I don't normally do. You know what that is? We're going to talk about 3D printing. And some of you might recognize this. This is a Creality 3D from an Ender3 board. I picked up one of these earlier this year, and that board went down on me after 2 weeks. So after trying to flash it, put a bootloader on it, and every other thing you can possibly think of, all looked up on YouTube, I finally come to the conclusion that it wasn't happening with that board. It would power up, but something was wrong. It wouldn't take any flash or anything that I did. So I ended up getting a Duet Maestro board. And what I'm going to show you is how I upgraded my Ender3 to the Duet Maestro.
Alright, we'll start with just some schematic pictures. This first photo happens to be the Duet Maestro board from an actual photograph with labeled connectors there. The second picture is the pinouts and what they mean on the Duet Maestro. And the picture after that is the wiring diagram to connect a single cable operation to the Ender3 menu screen, and it's connected to 2 of the Maestro connectors, but only goes into the third socket on the Ender3 screen. You'll notice the first 2 positions for ribbon cables are blank. Now they have a plastic type connector there, and you can pull those off, those clips off, and turn them around. And there's a video of mine with the single cable, but you'll notice those first 2 clips are flipped the other way. That's because there's a way to connect this with 2 cables going into the first 2 sockets on the Maestro board, but for some reason in my case I couldn't get the display to come up that way, so I finally got it to work using the single ribbon cable connection with all these jumper wire pinouts as shown in this particular picture. In this section you'll see that I connected the Maestro board to the standard box. Instead of using a special type of connector, there are those on the internet out there you can get that shows how you can just print a 3D template type mounting bracket and mount it to the normal case. In my case, I do a little bit of machining work and things like that. Here I just use a long screw and use 2 nuts as a standoff. On 3 of the corners I use the nuts. On one of the corners the nuts were going to overlap possibly and short out the board, so I took my machinist lathe and I spun those nuts down and cut all the corners off so they're 2 round, basically like a bushing on that particular corner. After mounting the board, I took a Sharpie and outlined the connectors for the SD card, for the USB, and also for the network cable, and then I took a Dremel and cut those out, and you can see that video in the video. Now you can see the ribbon cable connections after the box has been reassembled and installed, and you'll notice that the ribbon cable, after I used all the jumpers on the first 2 positions on the Maestro board, is connected to the position 3 on the original Ender3 display. Also, if you look close at this, you'll see that those slots 1 and 2 on the Ender3 display, the connector brackets, little black boxes there, have been flipped the other direction because I tried to use the simple 2 cable connection system, and like I said before, for me it just wasn't working out for some reason. Now I'm just showing everything all put back together again, and that this is just a stock Ender3 from Creality 3D printer. Has the same 24-volt fans, nothing fancy, nothing changed really. All this is showing is that I swapped out the board for the Duet Maestro. The reason why I emphasize this, I'm trying to show how you can do it with the original parts, because some other people out there do a fantastic job and they'll put on a BL Touch, or they'll put on some of these extra accessories, and that works out great, but it doesn't help when you're trying to use some of the regular stock parts to know what to do. And so we'll move on to the next scene, after showing it put back together, once again it's going to review really quickly that ribbon cable setup for the single operation. Then it will dive right into first the heating of the nozzle. And you'll notice there's two red wires that go into there. I color-coded one with a Sharpie black on one end to show that that is the negative side, and then it goes to the positive side. Right below that, where my finger is going to touch, shows where the thermistor goes for that particular sensor. Next, we have the connections of the stepper motors. They go the same way that they do on the Ender board. Just plug them in directly. Some people will shave off one little piece of the tab so they fit in smoother. It's not really necessary, but they go in order Z, Y, X, and the EO is the extrusion motor, all in a row on this board. After that, you might notice that some of mine have colored wires. That's because the X and Y stepper motors I have running through smoothers. That's the only modification I decided to try on this installation, and I just made sure the board connections were covered with tape so that they didn't rub against something and short out. Now we will talk about something a little bit harder to do. The stepper motors I use are using the standard end-stop micro switches. Those little cable connections are only 2-pin, but on the Maestro board they're 3-pin. So I use jumper wires to run into the original connector, and you have to connect them on the outside pins on the Maestro board. The inside pin isn't used and it'll cause a short. So you want these two wires to go to the two outside on the corresponding end stop points on the Maestro board. Next, we have the wiring of the fans. You'll notice that in this particular shot of the fans, there's a jumper toward the bottom of where the two wires go in. This jumper goes 5 volt or 24 volt. This first particular fan connection here is turned on by a thermistor for the extrusion head. When it reaches over a certain temperature, which you can configure on your own, that fan will turn on. And I happen to have both of this single jumper going to both fans that are working on the extrusion head in this case. The other fan that I'm showing on the far side is also jumper 24 volts, and that's the cooling fan for the Maestro board itself, and that's always on. There's two other sets of jumpers in the center, and those are being able to be controlled fans, and I just chose not to use those, but I set all of these up so that they can be done with the 24 volt fans instead of having to buy 5 volt fans and changing everything around. You'll also notice the jumper is on the left hand side with the right hand pin showing, and that is the correct position for 24 volts. The positive in this case is the orange wire, and in the always on fan it's the red wire, just so you make sure you get that checked correctly. You can always of course use a voltmeter and make sure it's done right that way. Last, we have the main power for the Maestro board. You can look at that. It's under an amber cover. The very first two on the far left are for powering the board. The next two on the right hand side are for the heated bed. And just right of that, as you see me point to, is the thermistor for the heated bed. Everything else is pretty straightforward. I've already covered it. You'll also hear me talk a little bit about other configuration tools in this that are used on the internet to get everything to talk to each other, and a video of a hard copy sheet that I made with the settings that I use that I found are working the best for now. Doesn't mean they can't be and that they're perfect, but they have been working for me. This is just a quick clip of the Yak Terminal. You can use this to get the IP address. That's how I got mine right there. You just type in the M552 command down at the bottom down here. It hooks up to whatever COM port that you're working with on it. In this case, I just hooked up the Duet Maestro to the USB, loaded the drivers for it. That's a totally different process. You want that, you can find it on YouTube. I'll give you a couple links to other videos that describe this a little more in detail. But then the Yak tells you what your address is going to be. You type in that IP address right there, or in your case the one that you have for you, and it will bring you automatically up to that page right there that connects everything to your Duet Maestro card. Works great. I also have it connected to my iPad. I can control it from there as well. I'll show a picture of that later. This is just a quick shot of the Duet Maestro interface with the IP address up here. You can see by my thumb on my iPad. So I can actually go over and check it all out and load files and do whatever I need to do right off my iPad or my computer. So it is hooked up to Wi-Fi, but it's a direct cable connection to the router, and then of course the router does the Wi-Fi, so I didn't need to buy the Wi-Fi version of the Duet. I just bought the Maestro. After a ton of hours and a bunch of work, this is about the best configuration file for the Maestro that I came up with, that uses most of the common fans and other things that came with the Ender 3. This also includes the code at the very bottom to activate the screen for the display, and that's a different animal all by itself. Alright, this is just a sample of the main menu for the display. Really quick, you can see I called my 3D printer Captain Desmond because I'm a captain with the airline. And that's done in the editor. Of course, hit Save Changes right there. Pull this back a little bit. This is found in the Settings tab over here. Display Editor Main. Then it brings it up right there. And as you can see, before I put everything back together, it shows up right there on the screen. Okay, now briefly but quickly I'm going to go through this RepRap firmware configuration tool. Now I'm not going to spend a lot of time on it because most of the information is on the document that I videoed that I did, and you're going to have to hand put in some of the things because this will not put in all of the configurations. First thing you need to do is just go RepRap firmware configuration tool at the command prompts right up here. You'll get to that tab. You want to do custom configuration next. You want to make sure that it is on a Duet to Maestro. I have it configured for compatibility with Marlin because that allows it to work with a couple of the other different types of software like
chronophase, and a few of the others that you might be accustomed to. Okay, always do save print state on power failure, leave that setting alone. The X and the Y, if you look at your Ender 3, should be 220 by 220 by 250. Now, sometimes I put 240 right here, but 250 is what it says on the specs. These are important because if you don't click these, you won't have any luck at first. The X and the Y actually are backwards on the way that the engine is for the drives. Z is forward, and the drive direction on the extruder is also backwards. These are left at 16. That one, we'll go ahead and we'll delete that one. That's at 400. So you'll get 80, 80, 400, and this one will make 95. Okay? There's a bunch of these other values that will change, but those values, if you look at max instant speed change, max speed acceleration, motor currents, and everything else, you will see those actually right here in documents right here. So this gives you your max steps, micro stepping, max speed, max acceleration. They're all right here. You just need to go in manually and put those in. I'm not going to take the time to go through all of those. I just want to make sure you see that it's important that you have these backwards, backwards, and backwards, and this one's the only one that's forward on the Z-axis. Then you're going to come down here and hit next, and in my particular build, I don't have a Z probe, so I make sure that's off. These values you can set up for those types of things. You do have the switches. I use the switches on mine. They're normally closed switches, which means that if they're continuity checked, they're going to show that it's a solid connection. The end stop is also at the low end on all three of those. If you don't, you're not going to get your homing positions correct on the X, Y, and Z axis. I'm not going to worry about these right now, but I wanted to make sure I pointed out those specifics. Okay? Heated bed is present. This one should stay the same. I leave mine on bang bang on there. I'm not worried about that. Just like I say, these things here, if you look at the documentation, you can manually put those in later. I don't have a tool configured on it, so I'm not worried about that. This should show you your bed length again. We put those in earlier, 220, 220. Those are some other custom settings. I just make sure these match on the document that I already showed you. Put in your printer name here if you want to. I called mine Duet Maestro right there. I leave this the same as it is right now. It seems to work fine. These are fans. And when you finish, it's going to save them all right here. You can download the configuration bundle like that. Downloads it, and at that point, when you go over and you find out where your particular address is on your network to make the Maestro work, mine happens to be 192.168.1.91. You can figure that out a couple of different ways, but when you do that, what you would do is you come over to settings, upload files, and I'm not going to do it, but here's some configurations that I did. The configuration that you saved, you'd click on that one, hit open, it would upload all of that data to your board. Okay, and then I go to System Editor right here. config G. That's the one that we set up, and this is how it looks like on the paper that I showed you. Then I manually went in and changed these, and the codes are on the side. So for instance, we were talking about the motors going forward or backwards. Drive 1 goes backwards. Drive 0 go backwards. Drive 1 goes backwards. Drive 2 goes forwards. And the extruder, drive 3, goes backwards. All the codes are right here. So as long as this and this match these here, then you should be able to use your fairly stock Ender 3 using the original 12-volt fans, okay, and the display, if the display is hooked up properly, and I'll try to show how I did mine. Now there's a couple of ways to do this display, and I mentioned it before. One with 2 cables, and you go in the back and reverse the clips, and you hook those up to the board's 1 and 2 slot. In this case, this is a single cable, and it's hooked up to number 3 slot on here, and it has a bunch of jumper pins going to 1 and 2 on the Maestro board, which is of course down here. Everything else on this system is pretty much a stock system. I didn't change anything. Still using the same steppers, same cooling fans, same extruder, nothing fancy. I'm printing right now a special board that helps with the cooling ducting and stuff like that I'm going to print out. I'll take out the original fans and it'll screw into this and give more uniform cooling for the parts. I'm excited to do that, and I'll show credits to people of where I got that from, and they're fantastic helping me to get this done. They did some of the work, and some of their information I used definitely got me on the right track, but for the most part they were bits and pieces that helped me put together all of the rest to get this to start working properly, and that's why I'm making this video. For those of you who don't have all the extra little fancy gadgets that you're putting on there, the heat sensitive probes, any of the other type of equipment that people are upgrading this unit with. This is just basically out of the box, swap the boards, and I do have the Ender Pro, so I have the magnetic top, and I got a glass top for it as well that came with it. Everything else just is whatever I got out of the box. And originally, the only reason why I did this in the first place is that this darn board they sent it with only worked for about 2 weeks, and then it blew out on me, and I couldn't get it to take any kind of reboot or anything. I tried everything you can think of to try to reload the stuff on the chip, and it's just dead. Nothing worked at all. I mean, I can get the board to power up, but no data, no code, no nothing on it. So it's like the CMOS chip is fried or something. I don't know, but tried bootloaders, tried everything. So anyway, appreciate it. Thanks for watching, and subscribe. And I do a lot more than just 3D stuff, as you've seen on my channel. So happy 3D printing.